Okay, I'm going to go through another example of evaluating an integral using u substitution with a definite integral. And once again, you have this function composition where you have the 2x minus 1 under the radical, but the derivative of that 2x minus 1, which would be 2, doesn't get rid of the x in the numerator. And so what I'm going to do with this is to try that change of variable idea. I'm going to try to write x in terms of u. Then du is equal to 2 dx, and 1/2 du is equal to dx. So I swap out the things that I have there. I still have that x left over, and I still have my limits in terms of x. So next I'm going to rewrite my limits in terms of u. And I want to know what is u when x is 5. Well, that would be 9. And then I want to know what is u when x is 1, and that would be 1. So the only thing that I'm missing here is I need to rewrite x in terms of u. And we actually did this particular substitution earlier, and we get x is equal to u plus 1 over 2. Now I'm going to put all the pieces together very carefully. And first I have a half from the 1/2 du. Then I have the integral from 1 to 9, and the u plus 1 over 2. And then in my denominator I have u to the 1/2. And that's all with respect to u. Now the 2 is really 1/2 times the integrand, so that can come out. And here I can actually split these up into two separate fractions, and they can be simplified a little bit more. If you note that u is really u to the 2/2 over u to the 1/2 is just u to the 1/2. And 1 over u to the 1/2 is really u to the negative 1/2. And so finally I'm in a position to find the antiderivative of u to the 1/2, which is 2/3 u to the 3/2. And for u to the negative 1/2, that's going to be u to the 1/2 over 1/2, or 2u to the 1/2. And that's from 1 to 9. So I have 1/2 times the quantity 2/3 9 to the 3/2 plus 2 times 9 to the 1/2. And then since u is equal to 1 in the second, when we evaluate the antiderivative at the lower limit of integration, 1 to the 3/2 is 1, 1 to the 1/2 is 1. So we're going to get 2/3 plus 2 as that second expression there. Make sure you put that in parentheses or take care of the negatives. So just in case you don't remember, how do you evaluate 9 to the 3/2 power? Remember, a rational root is power over root. And you can take the root first and then raise that to the power. So the square root of 9 is 3. 3 to the 3rd power is 27. 27 times 2 is 54 over 3. And 54 over 3 is 18. Square root of 9 is 3 times 2 is 6. Then we need to add 2/3 and 2, and that's 2/3 plus 6/3, which is 8/3. So we have 24 minus 8/3, and 24 in terms of thirds would be 72/3 minus 8/3, which would be 64/3. And that should give us 32 over 3. So anyway, this is as complicated as they get. We had to swap out the x in terms of u. We had to do the u substitution. We had to change the limits of integration from x's to u's, etc. But that's as bad as it gets with this type of problem. And so you should be very prepared now to handle most, or if not all, of the questions in the homework for this section.